Hello, class. Today we're going to go ahead and go over the 4.3 notes in Algebra 2, graphing quadratic functions. We'll go over some vocabulary first. First of all, we're going to go over what vertex form is. Vertex form is the function for a parabola. So this is going to be a U-shaped graph. And it's y equals a times in parentheses x minus h squared plus k, where h comma k is the vertex. And the pattern is whatever a is times 1, 3, 5, 7. So this is all the information you would use to graph a parabola in vertex form. Absolute value function is similar, except for it's v-shaped. So it's y equals a times the absolute value of x minus h plus k. Okay, so absolute value functions are v-shaped. Their vertex is still at h comma k, but the pattern is different. You take the a in front times 1, 1, 1, 1. So we're going to go over how to graph these today. In the first example, we have y equals x minus 2 squared plus 3. Let's figure out the basics first. For the vertex, we're going to use the opposite value for x. So since this is a minus 2, we use a positive 2. Okay, so for x, use the opposite, but for y, it stays the same. So we use a 3 for y. So our starting point for this parabola is 2, 3. The pattern, since there's no number in front, for a, the pattern is just the 1, 3, 5, 7. We'll go over axis of symmetry and the maximum or minimum after we graph this. So I'm going to plot that vertex 2, 3, and then use my pattern from that vertex to create the rest of my U. So from 2, 3, I'd go right 1, up 1, and then I go right 1, up 3, and then if I had space, I'd go right 1, up 5. So notice the 1, 3, 5, 7 are how far up you go. We always go right or left 1. So here I go left 1, up 1, left 1, up 3, and if I had room, I'd go left 1, up 5. And then you would connect these with lines and arrows on either end. Now the axis of symmetry, let's go back to that. That's where you could fold your graph in half and it would lay on top of each other. Both sides would be on top of each other, okay? So that axis of symmetry goes straight down the vertex like that. We use an equation for this, and it's x equals whatever the x value of your vertex is. So here it would be 2. So your equation for that yellow axis of symmetry is x equals 2. When they ask about maximum or minimum, they're referring to the vertex. The vertex is the minimum if it's the lowest point of your parabola. It's a maximum if it's the highest point. So in this case, it is a minimum. And we're done with that problem. Now, part B is absolute value. So instead of a U, this time we have a V. Still a similar process. The vertex is the same concept. So we use the opposite for X, which means we're going to use a positive 3. Use the same for Y, so it's a positive 5. Recall our axis of symmetry for all these graphs is x equals whatever our x value of the vertex is. So it will be x equals 3 for this one. Our pattern, since it's an absolute value graph and there's no number in front, our pattern is going to be the 1, 1, 1, 1. Now let's go ahead and graph it, and then we'll determine if the vertex is a maximum or a minimum. So I'm going to go over 3, up 5 to plot my vertex. Since my pattern's 1, I just go right 1, up 1, right 1, up 1, and I continue that pattern. I also, going back to the vertex, will go left 1, up 1, left 1, up 1, and continue that pattern. And then I draw lines with arrows on either end. Looking at this graph, that vertex is the bottommost point, so it is a minimum. And we're done with that problem. for part C. Normally, the vertex comes from a value attached inside parentheses with x, right? So our x value comes with whatever number is next to x, and then our y value is the plus or minus number at the end. Well, we don't have either of those. So if there's no value that's being added or subtracted to x in parentheses, it's a 0 for our x value. And there's no number on the outside, which means our y value is also 0. So we are starting at the origin for this problem. This means that our axis of symmetry is at x equals 0. Now for our pattern, this -2 affects our pattern. That means we take the -2 times the typical parabola pattern of 1, 3, 5, 7. So our pattern is going to be -2, -6, -10, and -14 this time. Again, I took the value in front of the x that's being multiplied by that, and I multiply it by our original pattern. So let's go ahead and graph this, and then we'll figure out if it's a maximum or minimum. I start at 0, 0, that's my vertex. For my pattern this time, I'm going right 1, but then since it's a -2, I go down 2. Then I'll go right 1, and then I go down 6. I'll do the same thing on the other side, left 1, down 2, left 1, down 6. And then I draw my lines with arrows. So notice on this one, since our pattern was negative, our vertex is the highest point, which means it's a maximum. Also notice that this graph is a lot skinnier than a normal graph with a normal pattern. Okay, so it's a narrower graph. All right, let's go ahead and look at part D. We have y equals 1/2 times the absolute value of x plus 1 minus 1. It's an absolute value graph, so it's going to be a V. My vertex is still the same method. I use a -1 for my x value and a -1 for my y value. Our axis of symmetry, again, is x equals the x value in our vertex, so it's a -1. This time my pattern is affected by that 1/2. We take the 1/2 times our original pattern. So 1/2 times, normally our pattern for absolute value is 1, 1, 1, 1. So that means our pattern is 1/2, 1/2, 1/2, 1/2. So let's graph this, and then we'll determine the maximum or minimum. I start by going left 1, down 1. That's my vertex at -1, -1. And then I use my pattern of 1/2. It is a positive 1/2, so I'll be going up. But this means I go right 1 and I go up a half. Right 1, up 1/2. 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 So notice it takes me going right 2 to go up a whole. And we do that on both sides. And then I draw my lines with arrows. Looking at this, our vertex is the lowest point, so it's a minimum. And that's it for that problem. Okay, so now we're going to move on to something called completing the square. So every once in a while, our equations are not going to be in vertex form. So to graph them, we're going to want to put them in vertex form. Okay. Completing the square is where you rearrange a quadratic function, y equals ax squared plus bx plus c, into vertex form, which is y equals a times x minus h squared plus k. So with completing the square, we are rearranging the quadratic. We're making it look in a new form so it's easier to graph. So for example 2, we're going to go ahead and complete the square so that we can graph it. When we complete the square, we want to start by splitting up this problem. So I'm going to write the y equals x squared minus 10x on the left. I'm going to give myself some space, and then I'm going to put the plus 27. Now I'm going to take this -10 from the middle term. I divide it by 2, which gives me -5, and then I square it to get 25. So we will always do this process of taking the middle term, dividing it by 2, and squaring it. Whatever we get, we'll put after the middle term. So I put a plus 25 here. Okay, so notice. I got 25 when I divided by 2 and squared it. I put the 25 here. However, we're not trying to change the value of this problem. So we're going to do the opposite to the right-hand side. So since we added a 25 on the left, we're going to subtract 25 on the right, because essentially 25 minus 25 will cancel out. It's as if we never did it. Now the reason we did this whole dividing by 2 and squaring it is so that we would get something we could factor here. So x squared minus 10x plus 25 is factorable into x minus 5 squared. If you don't want to go through the process of factoring it, you just need to remember that you take whatever you got when you divided by 2, and that's the value that goes here. Then our last step is take these last two numbers, 27 minus 25, we combine them to get a plus 2, and it goes at the end. So x squared minus 10x plus 27 in vertex form is x minus 5 squared plus 2. This makes it a lot easier to graph. So let's figure out our vertex. Vertex is found the same way we were in the other problems. So it's going to be a positive 5, positive 2. Since we have no value in front of our parentheses, our pattern stays the same as 1, 3, 5, 7. So I'm going to go over to 5, 2. 1, 2, 3, 4, 5, up 2. And then I'll use my pattern 1, 3, 5, 7. So I go right 1, up 1, right 1, up 1, 2, 3. And then I could go right 1, up 5. Go back to the vertex, go left 1, up 1, left 1, up 3, left 1, up 5. Draw my lines with arrows, and I am done. So that's it for this example. For the next example, we're going to convert the quadratic function f of x equals 3x squared minus 18x plus 23 into vertex form and graph. So we're doing that, completing the square again. This one's a little more difficult because there is a number or a coefficient in front of our x squared term. I'm still going to begin by splitting this up. So f of x equals 3x squared minus 18x. I'm going to give myself some space and put the 23 on the right. Now before we can take that middle term, divide it by 2 and square it, we have to get rid of this 3 in front of the x squared. So I need to factor a 3 out of these first two terms. If I do that, I get x squared minus 6x. Note, I factored the 3 only out of the first two terms. I have not done anything to this plus 23. It stays as is. Now that there's no value in front of that x squared, I can take my middle term of negative 6, divide it by 2 to get negative 3, and then square it to get 9. That means I put a plus 9 after the minus 6. I'm going to close my parentheses. The reason I did that is because notice this entire trinomial here is being multiplied by the 3. So I'm not putting a minus 9 on this right-hand side like I was in the example 2. I have to take 3 times 9. So really, I'm changing this by adding 27. So to cancel that out, I need to subtract 27 here. Okay, so again, I didn't really add 9 because I'm multiplying by that 3. So I added 27, which means I need to subtract 27 on the right. Okay, so now I'm going to bring down that 3 that's in front. X squared minus 6x plus 9. To factor it, remember I can use this here, x minus 3 squared. And then I'm going to take 23 minus 27, which is minus 4, to put at the end. So my vertex form is f of x equals 3 times x minus 3 squared minus 4. Now it's going to be easier to graph. My vertex is at 3, negative 4. My pattern this time is affected by that 3 in front, so it's 3 times 1, 3, 5, 7, which means our new pattern is 3, 9, 15, and 21. Okay, so I'm going to go to 3, negative 4, put a dot. Now I use my new pattern, right 1 up 3, right 1 up 9, and that's as far as I can go using that pattern on this graph. I'll do the same thing on the other side. So I go back to my vertex and I go left 1 up 3, left 1 up 9. And I connect my dots with lines and arrows. And that's it. Okay, so in Example 4, it says to find the real zeros of the function f of x equals negative 2x squared plus 16x minus 22. So finding the real zeros means that we're trying to find out what x equals when y is 0. What is x when y equals 0? That's what it's asking. Okay, so let's start by making this 0 equals negative 2x squared plus 16x minus 22. Okay, so there's two options. We can either try to factor it first and see if that works, and then if that doesn't work, then we would need to do the completing the square process, or we could use quadratic formula. I'm going to see if we can factor it. So 0 equals, I'm going to take out that negative 2 first, because everything is divisible by 2. That gives me x squared minus 8x plus 11. Now looking at this, 11, there's no factors of 11 that'll give me a negative 8. So now I know I can't factor that. We're going to have to scratch that off. We're going to have to go back to the drawing board. Let's go ahead and try completing the square. 0 equals negative 2x squared plus 16x. I'm going to move the negative 22 over. Now, I'm going to take a negative 2 out of those first two terms. So I get negative 2 times x squared minus 8x. Notice I didn't do anything to the minus 22. I'm going to take that negative 8, divide it by 2 to get negative 4, square it to get 16. So I can put a plus 16 here. But because of the minus 2, it's really a negative 32, right? Negative 2 times 16 is negative 32, which means I need to add 32 on the right. So I get 0 equals negative 2 times x squared minus 8x plus 16 factored is x minus 4 squared. Negative 22 plus 32 is positive 10. Okay, so now 0 equals negative 2 times x minus 4 squared plus 10. We can solve this. I'm going to go ahead and subtract 10 from each side. So I get negative 10 equals 2 times x minus 4 squared. I'm going to divide both sides by the negative 2. So I get 5 equals x minus 4 squared. Now I can square root both sides. So I get the square root of 5 equals. Recall, whenever you square root a squared quantity, it becomes an absolute value. So I have the absolute value of x minus 4. I split this up into x minus 4 equals a positive root 5. X minus 4 equals a negative root 5. Now, when I add 4 to both sides for both equations, I would get x equals 4 plus root 5, and I get x equals 4 minus root 5 as my final answers. Okay, so those are our real zeros. That's what x is when y is equal to 0. These are also our x-intercepts. All right, so for the next problem, we are finding x and y intercepts. This is similar to finding the zeros. X-intercepts is going to be a little more involved than y-intercepts. Okay, so for y-intercepts, we make x equal to 0 and solve. For x-intercepts, you make y equal to 0 and solve. Let's find the y-intercept first because it's easier. To find the y-intercept, I make x equal to 0. So f of x, but x is 0. So I'm going to say f of 0 equals 2 times 0 squared minus 4 times 0 minus 1. Well, 0 squared is 0. 0 times anything 0. So notice this will go away, and we have a negative 1. So this tells me when x is 0, my y is negative 1. That is my y-intercept. Now for x-intercepts, we need to make y 0 and solve. So 0 equals 2x squared minus 4x minus 1. This is not factorable. Let's go ahead and complete the square. It'll be good practice. 0 equals, I split it up, 2x squared minus 4x. Move the minus 1 over. I am going to factor out that 2, so I get 2 times x squared minus 2x. Minus 1 remains the same. Now I can take that middle term, negative 2, divide by 2 to get negative 1, and square it to get a positive 1. So I put a plus 1 here and close my parentheses. Now remember, we got to take this outside number and multiply it by that last term. We really added 2, so on the right I need to subtract 2. I get 0 equals 2 times x squared minus 2x plus 1. Factored is x minus 1 squared. And then negative 1 minus 2 we bring down to get minus 3. So now that we have put this in vertex form, we can use the square root method of solving. So I'm going to get the squared part alone by adding 3 to each side. When I do that, I get 3 equals 2 times x minus 1 squared. Divide by 2. So I get 3 halves equals x minus 1 squared. Square root both sides. So I get the square root of 3 halves equals the absolute value of x minus 1. Now, the square root of 3 halves, that's like the square root of 3 over the square root of 2. I cannot have a square root on the bottom, so I need to rationalize it by multiplying top and bottom by root 2. So I get root 6 over 2. This is the correct way to write it. So when I split this up, I'm going to write it as square root of 6 over 2 equals x minus 1, and negative square root of 6 over 2 equals x minus 1. Because remember, when we split it up, we make it equal to a positive and a negative. Then I'm going to add 1 to both sides. So I get square root of 6 over 2 plus 1 equals x. Negative square root of 6 over 2 plus 1 equals x. So as x-intercepts, it's root 6 over 2 plus 1 comma 0. And negative root 6 over 2 plus 1 comma 0. And that's it. Keep in mind, completing the square is not the only way to do this. You could have also used quadratic formula. You can also use quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all of this over 2a. So that could have been a choice. I just wanted to practice completing the square with you guys. I feel like it's important to practice that when we get the opportunity. But if quadratic formula is easier for you, that is also a choice. And that's it for the notes today. If you have any questions, be sure to contact your teacher.